Hello viewers, I welcome you all to Sunya IS, and as you can see that today we are with a new worksheet, and this is on the topic of composition and structure of atmosphere. Alright friends, so this is the continuation of the Prelims 2023 crash course, and we are today going to see a new worksheet. Alright, so let's look over the questions. The first question says that the ultraviolet solar radiation is largely absorbed by. Okay, so friends, we know that this is your Earth, and we have several layers. The troposphere is there, and then tropopause we have. Okay, and then we have stratosphere. Okay, so we have several layers, and in stratosphere we have this ozone layer and all. And this is your Earth, right? And this is your Sun. Now the ultraviolet rays, which are which are coming to the Earth, this is largely absorbed by what? This is the question. First is carbon dioxide and nitrogen. Second is oxygen and carbon dioxide. Then C is oxygen and ozone. And D is your nitrogen and ozone. All right. So friends, we know that, this maximum solar radiation which is coming, that is absorbed by ozone in the stratosphere. Okay, this is your, as I've told you, this troposphere and then stratosphere. So in the stratosphere, we have this ozone layer. All right, so this is definitely ozone would be one option over here. Okay, and some of the other parts of the ultraviolet that is, absorbed by your oxygen, your water, okay, carbon dioxide, all these things are responsible for the absorption of the ultraviolet solar radiation. All right, if the radiation is from the Earth, that is in the long wave form, then this is called as terrestrial radiation. The incoming radiation from the sun, that is called as your solar radiation. Okay, so here, if we see, then definitely ozone would be one of the correct option that we all know. Okay, maximum ozone, it absorbs the ultraviolet solar radiation. So this option and this option is eliminated. Now the options can be either C or D, ozone and oxygen, and nitrogen and ozone. All right, but again, the absorption of this ultraviolet solar radiation is because of oxygen, some water vapor, carbon dioxide. Okay, so here oxygen and ozone is one of the option which is correct over in the given statement. Okay, so here we will have the correct option is option C, that is ozone and oxygen. Now UPSC could have given it as carbon dioxide and ozone, then that would have been the correct option. Okay, it would not have been in both the options would not have been given. That's why you can see that the options is given in different manner. The concept has to be clear to solve these type of questions. All right. Okay, let's look over to the next question now. This next question, number 2, is asking about the most significant variable gases. Okay, so it is asking that which are the variable gases in the atmosphere. Now, first, what is this variable gas all about? Okay, so variable gas basically are the gases which are present in, these are present in small amount. Okay, these are present in small amount, and being present in small amount, they are variable. Okay, small amount and in variable amounts as well. So, and these gases, they are carbon dioxide, we have methane. Okay, methane we have, then we have ozone, then we have water vapor, all right, and other particulate matters as well. Other particulate matters as well. All right, so these are the significant variable gases. Now, this, if these are the variable gases, then the gases like nitrogen, okay, the gases like nitrogen and oxygen, these gases basically they remain fixed. Okay, they remain fixed, and they remain fixed in the atmosphere, and neither they do change in with the changing temperature and atmosphere, or temperature and season, if you if in particular you talk about. Okay, so these are the gases which are fixed gases, and these are the variable gases. Now, if you talk about H2O, that is water vapor, this is somewhat around 3% to 4%. Again, it can be, again, it can vary from 0 to 4%, to be very frank, because there can be places where no water vapor is present, and 4% of maximum water vapor can be available. Okay, if you talk about carbon dioxide, okay, so this is also 0.03% by volume. Okay, but we had seen that the amount of carbon dioxide that is increasing. That is increasing as of now. Okay, so in this question, the correct option would be variable gases. It is asking, so oxygen will be removed, nitrogen will be removed. Okay, your water vapor and oxygen. Again, oxygen is not a variable gas. These are fixed gases. So you eliminate one, A, B, and D, and the left option would be option C, that is water vapor and carbon dioxide. All right, let's look at the next question now. The next question is asking about temperature inversion most frequently occurs in. See, it is asking more frequently it is occurring in. Okay, now we have one concept as your normal lapse rate. Okay, we have this concept of normal lapse rate. Okay, now what is normal lapse rate? Normal lapse rate is that when you increase the altitude, when the altitude is increasing, okay, so the temperature will reduce. With increasing altitude, the temperature reduces. Okay, and that reduces off to 1 degrees per 165 meter. So if you go 165 meter in height, so you will find a reduction 1 degrees in temperature. Now this is normal lapse rate. Okay, in some situations, what happens that this normal lapse rate, it gets reversed. Okay, and in reversal, what will happen? In reversal, the temperature, it starts to increase with increase in altitude. Okay, so as the altitude is increasing, the temperature also starts to increase. Okay, this is basically known as your temperature inversion. Okay, this is basically what is known as your temperature inversion. All right, now temperature inversion that will occur in your upper troposphere. See, this is your earth. Okay, this is your earth layer. This is your layer of earth. Okay, now when we go up high in the atmosphere, this is your troposphere. Okay, this is your troposphere, and after troposphere there is a layer which is known as your tropopause. Okay, this is tropopause. After we reach tropopause, then we come with after tropopause, then there is a layer which is called a stratosphere. Okay, and then we have, after stratosphere also, we have a layer which is known as your stratopause. Okay, and we had also seen that how the temperature with increasing in height, it reduces and it increases. So when we go up high in the troposphere, then we all know that temperature, it decreases. Temperature decreases from here to here. Okay, temperature will decrease. Okay, temperature will decrease here. That is your when you go from when you go from the surface of the earth to the troposphere. Okay, now this upper troposphere, in the upper troposphere we have this tropopause. Okay, this is part of your upper troposphere. All right, and in this upper troposphere, what happens is that with increase in height, see, first the temperature in troposphere, what happens? That the temperature, it starts to reduce. Okay, it starts to reduce. Then this is your tropopause, and tropopause we start looking over to the change in temperature. Now the temperature starts to increase. First this is your troposphere, okay, and this is your tropopause, and then this is your stratosphere. Okay, so in this layer only, in the upper troposphere layer, we see that the temperature inversion starts to take place. That means the temperature, it breaks off and no more temperature is decreasing after the height is being increased. Okay, this is your temperature and this is your height. All right, so this phenomenon occurs in upper troposphere most frequently. Okay, so most frequently it occurs in your upper troposphere layer. All right, where we can see the sudden increase in temperature with increasing height. Okay, so here the correct option would be your upper troposphere. All right. Okay, now let's move on to the next question. Next question is asking that the lowest temperature is observed or recorded in which of the following layers of the atmosphere? The lowest temperature. Now this is also about the this also you need to have the idea about the atmosphere and the changing in temperature with increase or increase in heights and all right. So here if you see that this layer is your troposphere layer, which I was talking about. Okay, so temperature first decreases over here with height, normal lapse rate. Okay, then tropopause, upper troposphere layer, and then you can see that the temperature starts to increase. Okay, then again there is a pause and the temperature starts to increase over here because of ozone layer. Okay, now again we see that the temperature starts to decrease in mesosphere layer. Okay, and temperature reaches its minimum, minimum level in your troposphere, sorry, in your mesosphere, upper mesosphere layer. And after the mesosphere, the mesopause comes, and then when when we enter into thermosphere, then the temperature increases drastically, and then the temperature keeps on increasing. Okay, so in this mesosphere layer, we can see that the minimum temp, see over here, if you see over this graph, then this is the temperature, say for example, this is -50, okay, which is reached in troposphere or upper troposphere. And then in mesopause, in mesosphere, the temperature, the maximum temperature, the maximum dip in temperature, we can see that is somewhat around 85 -85 degrees to 90 degrees or some -90 degrees. Okay, so we can see over, okay, that the lowest temperature is observed or recorded in your mesosphere layer. All right. So here the correct, now the question can be also in other way, that the maximum temperature is can be seen in which layer, or the sudden change in temperature can be seen over in which layer. So these type of questions, the questions can be asked in any way. The only important thing is to understand the concepts, and if you are clear with them, then definitely the question solving won't be any problem. Now this question, which of the following cities has greater annual range of temperature? Okay, you have been asked here the greater annual range. Now what is the annual range? Annual range is the difference. Okay, it is the difference between your mean temperatures of the warmest and the closest coldest months. Okay, the difference between the mean temperature of the warmer or the warmest and the coldest month. That means if the if the month of May is the warmest, okay, or say for example the month of June is the warmest, and the average temperature is 38 degrees Celsius, and the coldest month, the temperature, it goes to around, say for example, it varies between 10 to 20 degrees in the winter months, and the average temperature you take it as 15 degrees Celsius. Okay, so the difference between the average temperature or the mean temperatures of the warmest and the coldest month, this is known as your annual range. Annual range of temperature. Because that means this is the range of temperature. The temperature can vary from 15 degrees to 38 degrees. This is the annual range. This is what is being, this is what is meant by annual range of temperature. Now, this question has been, this question has 3-4 aspects. The one aspect is importance of the mapping. Okay, importance of your mapping. This is one of the aspect which is shown over here. That means you need to know that where these locations are. These locations are located, or these places are located where. That is very important. Then with mapping, you have to understand and you have to know the concepts of concepts of climatology, and that those all things are important over here. Now, greater annual range of temperature will be always in a place which is far away from the sea locations. Okay, because we had seen and we had learned this in our classes also, that the more the place is near the sea, the more effect, the moderating effect of the sea is on the places, and the difference in temperature is not very high. The difference in temperature would be very less. Say, for example, if you take example of New Delhi, now those people who are staying in New Delhi, they can understand what I'm saying. In the summer months, the temperature of New Delhi goes to around 45 degrees Celsius. Okay, in the summer months, and in winters it also reduces to as minimum as 5 degrees Celsius. But if you are staying in coastal areas, like say for example, if you're staying in Kerala, okay, then this difference would not be more than 30 degrees or 35 degrees. Winter 30 degrees, in summers maybe maximum 35 degrees. All right. So this is what we had also studied in our concept classes, that how the moderating effect of sea and oceans, they have difference or they have their effect on temperature of the local areas. All right. Now let's look over to the options which are given to us. If you look over to the options which are provided to us, the first option is Kuala Lumpur. Now this is in Malaysia. Okay, again a location or place which is near to the ocean, okay, and has oceanic effect. Okay, so this statement, annual range, greater annual range of temperature, Kuala Lumpur will not be put there. Okay, Shanghai again has a moderating effect of sea or the ocean. Okay, so Shanghai will also not be there. Shanghai in China. All right. So options can be New Delhi or Ulaanbaatar. Now, Ulaanbaatar, this is the capital city of Mongolia. Okay, and you can see that Mongolia has very far distance from sea than that Delhi has. Okay, the distance between Delhi and Arabian Sea or Delhi and Bay of Bengal is not that much as your Ulaanbaatar is having. Now, temperature of Ulaanbaatar can be somewhat like, in winters, it can go up to extremes of minus 35 degrees Celsius, and in summers, it can go up to minus 38 to 40 degrees Celsius as well. All right, so this is the annual range of temperature. So definitely being away, a lot away from the sea, this Ulaanbaatar, this place would be having the greater annual range of temperature. Now, location is very important to be understood in these type of questions. If you have the idea of locations, then you can solve the questions. New Delhi would have been very cold, okay, but New Delhi don't has this range of temperature. The reason is that there are Himalayas present. Okay, the Himalayas which are present over, okay, these Himalayas, they stop this very cold waves coming from Siberia to enter the northern India. If these Himalayas were not present, then New Delhi would also have been this cold. All right. So again, these type of questions can be predicted in future. See, some questions are fact-based questions, and some questions are such questions which have the importance of the facts plus the understanding. So both the aspect become important in such type of questions. All right. Okay. Next question now. With reference to the structure of the atmosphere, consider the following statements. Okay. Now, what are the statements? The air density is very low in thermosphere layer. This is the first step. Now, layers we know. Okay, what are the layers? This is your surface. Okay, this is the surface of the earth. After the surface, we have your troposphere. Okay, after troposphere, we have your stratosphere. After stratosphere, we have your mesosphere. After mesosphere, we have your thermosphere. Okay, and after thermosphere, we have the space, that is exosphere. Okay, this is how the layers are present, and then tropopause, stratopause, mesopause, all these are present over here. Now, the air density is very low in thermosphere. This is the given statement. Thermosphere is very high. That is after the 3 layers which are present in the atmosphere. Now, the statement is definitely incorrect. Why so? Because, the maximum amount of density would be present in troposphere layer, within troposphere. And what is the reason? The reason is that the gravity of the surface of the Earth will try to, pull the dust particles or the or other water vapor molecules or other molecules to near it. And the lighter materials, they will move up high in the atmosphere. Okay. Second, the denser material will be sinking down. This is also what we know. So the denser the material is, it will sink down, and the lighter material, the material which has lighter density, that will be up in the high atmosphere. Okay, simple to understand. So this first statement is definitely incorrect over here. Third statement is density in the atmosphere is high near the Earth's surface and decreases with increasing altitude. Okay, density in the atmosphere is high near the Earth's surface. As I have told you that the maximum density would be in the troposphere layer. So this statement is definitely correct. First statement is incorrect. Second, mesosphere is the most important layer of all biological activity. All right. Now we have known this, that most of the changes in climate, or the maximum amount of uh, diversity, or water vapor, or the gases, or the life, the weather, atmosphere, climate, everything, this takes place in this troposphere layer. Okay, it takes place in your troposphere. So mesosphere is the most important layer for all biological activity. Mesosphere is after stratosphere and then mesosphere, and we know that the oxygen level, this also decreases a lot. Okay, and the maximum biological activity that they will be taking place between on the surface of the Earth or in the troposphere layer. All right. So here, this statement is also incorrect. This statement is also given incorrect. Okay. The air density is very low in the thermosphere layer. Yes, air density will be very low. Okay, this is low. I thought this is high. Okay, all right. So air density will be very low in thermosphere. Yes, that is right. The air density will be high in troposphere layer, because the density of the maximum amount of this water vapor and all. Okay, okay. This is low. All right. So this is correct. The air density is very low in thermosphere layer. This is given right. This is correct statement. All right. So statement 2 is incorrect over here. Correct option would be option C, that is 1 and 3. I hope you have understood. There is no doubt. Air density is very low. This is correct statement over here. Air density is high. Density of the air packet is high in the troposphere. So air density is very low. It is, it will be as low as, the lowest would be here, and then exosphere we have the space. Okay, so troposphere में it will be high, then it would be low in stratosphere. उससे भी कम होगा in mesosphere, and उससे भी कम होगा in thermosphere. So this is definitely correct. Air density is very low in thermosphere layer. ठीक है, no problem. Question answer C would be the right answer. Okay. Now let's look over to the next question. Now next question is asking the consider the following statements, and the three statements are given. All right. The first statement is normal lapse rate is when temperature decreases with increase in elevation. Okay. So we had seen that what lapse rate is. Okay. Lapse rate is when we go high in the atmosphere, or when we go high in the altitude. Okay. Increase in elevation, high in altitude, the temperature it decreases. Okay. So this is height and this is temperature. So this is correct statement here. We had just seen it. Okay. This is correct statement. Statement number 2, a long winter night with clear skies is the ideal situation for temperature inversion. This is also correct statement here. See, what happens is that, say, for example, this is surface of Earth, and during daytime, the short waves have reached the Earth's surface and they have heated the surface of the Earth. Now, what happens is that at night, there is again if the sky is clear, then it's all right. But if the sky is not clear, then what happens? This cloud formation would be here. Okay, such clouds can be formed over here. And when these clouds are formed over here, then what happens is that the terrestrial radiation, okay, which is your long waves which are going back to the space. Now this heat gets trapped because of these clouds which are present. Okay, so this heat gets trapped, and if the heat gets trapped, then the inversion of temperature is not possible. All right. But if the heat of the day is radiated back, if there is no clouds over here and the heat of the day is radiated off at night time, okay, if radiated off during the night, and by the early mornings, okay, what happens during winter seasons or very winter chilly nights, that the earth gets very cool, okay, than the air above. All right. So here it will be very cool and the upper air would be warm. Okay, so temperature inversion is possible if these cloud formations are not there. Okay, so we can say that this second statement is also correct, that the long winter night with clear skies is ideal situation for temperature inversion. All right, all these explanations and everything we had seen in our in our discussion, in our lectures, and in the crash course series which is going on. Third statement: the inversions of temperature do not affect the diurnal variations in air temperature. Now, this diurnal variations, what is this? This is the difference between the maximum and minimum temperatures of the same day. Okay, so diurnal temperature means, variation means that what was the maximum temperature and what was the minimum temperature in the same day. It is calculated for the same day. All right. So this inversion, temperature inversion, they will be having effect, okay, in the diurnal variations of air temperature. All right, because what happens, see, that during the day, the air, basically the air during the day, because in the daytime, the land gets heated. Okay, so the air in contact with land surface, that also gets heated because of the sun's radiation. And the heat from ground, they interact with the air by conduction and convection, as we know. So if the temperature of the surface of the earth will have an effect because of this diurnal variations. Okay, so if there will be diurnal variations of the air temperature, then inversion of temperature, that will also have effect of it on it, because inversion of temperature is also taking place in this in the same layer of with the which is having direct effect with the air temperature. All right. As I have explained to you that how the inversion of temperature takes place and what is it all about. Okay, so this third statement which is given over here, this is incorrect. It will have, so do not affect wala jo statement line, this is incorrect. So it will have the effect on the diurnal variations of air temperature. All right. So here 1 and 2 is correct and third statement is not correct. So correct option would be option A, that is 1 and 2. All right, let's look over to the next question now. The next question says, it is basically asking about the heat budget. Okay, we had studied heat budget in our lectures also. Now, with reference to concept of heat budget, consider the following statements. The first statement says that the atmosphere is indirectly heated by the Earth's radiation. Okay, atmosphere is indirectly heated by the Earth's radiation. Yes, definitely that is correct. Okay. See, the insolation which is issued by the Earth, that is the shortwave insolation. Okay, and that shortwave insolation, it heats the Earth. Now, Earth is heated, and when this insolation is not present, okay, so the heat of the Earth, it starts to radiate back, the terrestrial radiation, what we call. Okay, and when it radiates the heat, which is in the long wave formation. So this energy, this heat energy, it basically heats the atmosphere from below the terrestrial radiation. So this atmosphere above the surface is heated by this terrestrial radiation. All right, so first statement is definitely correct. There are several gases also, as I've told you, that atmospheric gases, like particularly the carbon dioxide and the water vapor and other greenhouse gases, they also lead to indirect heating of the atmosphere by the Earth radiation, because they trap the heat and they heat up the atmosphere then. Okay, and then the atmosphere in turn radiates and transmits heat into the space. All right. So fine. Then what happens that this heat is finally radiated back into the space. That is true. Okay, but atmosphere is indirectly heated by Earth radiation. That is a correct statement over here. Second statement is that the Earth as a whole does not accumulate or lose heat. Earth as a whole does not accumulate or reduce heat. का मतलब क्या है? कि Earth basically maintains its temperature. Okay, this is what it basically means, that Earth maintains its temperature. And it maintains its temperature if the amount of, and how does it do? If the amount of heat received, if the heat received, okay, remember the economic classes, if the heat received from the insolation, okay, heat received from insolation, that equals to the heat lost, okay, the heat lost through terrestrial radiation. If this equals, that means the temperature of Earth has been maintained, and as Earth as a whole does not accumulate or lose heat. Okay, so it does not accumulate or keep the heat with it. It basically releases the heat which it gains through solar radiation. So second statement is also correct over here. All right. If you remember the heat budget classes we had seen, and we have explained you each and every aspect, that what amount of heat is trapped by the atmosphere, what is radiated back as it because of the effect of scattering and all. So all those things, what we have discussed, the question directly deals with that. So here, which of the statements given above is not correct is being asked. Okay, so not correct to koi nahi hai, both are correct. So correct option would be then option D, that is neither 1 nor 2. All right. Okay, let's go to the next question now. Now, next question says that which of the following statements concerning temperature is or are correct? All right, the first statement says that the isotherms are irregular and very closely spaced in northern hemisphere. First of all, isotherms हैं क्या? Isotherms क्या हैं? Isotherms are the imaginary line. They are the imaginary lines which are joining the places, okay, joining the places which have the equal temperatures. Okay, they are the imaginary lines which are joining the places having equal temperature. All right, so in the Earth, this type of these type of lines we can see now. See, in the southern hemisphere, this is equator and this is the southern hemisphere. Maximum lines are parallel to each other, okay, because of the absence of landmass. Okay, and you see here that there would be a difference in temperature of the land and the sea. So there will not be a straight line when the temperature of the land, and when the there is a line which is isotherm which is passing through the land and the sea. So they will not have straight line. There would be a difference, or deviation in the temperature, because of the heating, the way the land is heated and the water is heated. All right. Now, in the northern hemisphere, what happens now? That when it is winter, the air over the ocean is more warm, and in the summer, the air over the land, that would be more warm. See, the reason is that, again, it is because of the difference in heating of land and sea. Okay, this is because of that. Now, because of this, what is happening, that the isotherms, they will be bending towards the equator when we are crossing the land, okay, and the polewards when we are crossing the oceans. All right, so when crossing the land, okay, so you can see over here on the land, they will be moving towards the equator. That means the temperature is more near to the equator, that is when temperature increases. And when it is over the sea, then the temperature would be reduced, it would be less, so it will be moving towards the polar regions. Even here also you can see like that. All right. And in the southern hemisphere, the isotherms would be uniform, and with this uniformity, they would be widely spaced as well, okay, in the southern hemisphere, because there is no deflection, and deflection is not because there is no land available. Less land is available in the southern hemisphere, so they are more or less parallel. Okay, so first statement is definitely correct over here. Second statement says that the isotherms are parallel to latitude in southern hemisphere in oceans. Okay, now as I have told you that in the southern hemisphere, the land mass is less, so the deflection is less. Less deflection means this is, say for example, the case in the southern hemisphere. All these places on the same latitude have the same temperature because they are all water. ठीक है, तो this would be isotherm. नीचे का और नीचे latitude में they will be having same, so this would be somewhat the isotherm. अब यहीं पे अगर land आ गया मान लीजिए, तो land आने की वजह से heating would be more. Okay, so it will turn like this. So isotherms will not be parallel when it is in the northern hemisphere, but southern hemisphere they are parallel to the latitudes. This statement is also correct over here. Third statement is minimum temperature during winter is recorded in northern Canada. Now this is incorrect. Okay, northern Canada में minimum temperature won't be recorded. That would be recorded in the area somewhere in Russia. All right. So third statement here is definitely incorrect. Correct statement would be 1 and 2. All right. So correct option would be correct answers. That is A, 1 and 2. Okay. All right. Now let's move on to the next question. Now this next question is asking about, consider the following statements. Now this is a very easy question. We have discussed these points while we were discussing other questions also. Consider the following statements. First statement says that the energy coming from the sun to the earth's surface has shorter wave and high frequency. Yes, this is correct. Now the energy coming from the earth's surface, basically solar, remember this solar radiation. Okay, solar radiation, this will be having shorter wavelength. And the terrestrial radiation will be having your longer wavelength. Now, if the wavelength is short, if you're a science student, you will know that if the wavelength is short, then the frequency is high. Okay, and if the wavelength is high, then the frequency will be less. The energy coming from the sun to the earth's surface has shorter wavelength and higher frequency. That is definitely correct over here. Second, during the cloudy night, clouds reflect back longer wavelength energy from earth's surface. This is also correct over here. Okay, this during this cloudy nights, what happens? The cloud reflect back longer wavelength. The longer wavelength is the terrestrial radiation. Okay, and this is this cloudy night में क्या होता है कि this is reflected back, and if it is reflected, when then the formation of this formation of dew, foggy fogs and all, this is not possible if there is a cloudy night. Okay, because why it is happening? Because in the cloudy night the heat is trapped. Heat would be trapped in the atmosphere. All right, heat would be trapped in the atmosphere, and this heat trap in the atmosphere will not allow these formations. Okay, when there is when the cloudless night is present, if there is no clouds, then heat energy from the earth is very freely released as terrestrial radiations, which is in long wave forms. Okay, and they will be released into the space, outer space. Okay, so no trapping of heat will be done when there is no clouds. All right, so here if by this question we go, then both statement 1 and 2 is correct. So correct option is option C, that is both 1 and 2. All right, let's go to the next now. Okay, so these were the questions which we had to discuss in this worksheet. So thank you for the session, and keep watching Sunya IIS. Thank you.